Hi there, let's do similar triangles. If you look at this thing in the corner, this is called a similarity statement. Triangle EFG is similar to triangle SRQ. Note the sign is a little bit different. It's like a congruent sign, but it doesn't have the line underneath it. Now, similar triangles are proportional. The sides aren't equal to each other, so you solve for something that's missing, like this, by doing a proportion. So it'll be four numbers we're going to pop in here. One of them won't really be a number. One of them will be the variable x that I'm going to use to stand for this thing. Now that missing side is EF. So that's here. I want to show you how to read these similarity statements. EF is going to be similar to SR on the other triangle. So SR is the 70. So we're going to put that down here. There's more than one way to set these up, but I always do it the same way. I put corresponding sides with each other vertically in my proportion. Then horizontally, I use a side from the same triangle of the one I'm looking for. So I have to use this 84 right here. And then the 84 corresponds to the 30 because FG corresponds to RQ. So we'll put the 30 right here. You can set this up a little differently. Like some people would do x over 84 equals 70 over 30. But what you want to watch for is that things line up. I have corresponding sides going up and down. I have the same triangle going side to side. Now, to solve a proportion like this, you just cross multiply. We have 30x equals 70 times 84. We have 30x equals 5,880 when you multiply that out. Now divide both sides by 30 and we get x equals 196. So this side is 196. Now that's when everything is pretty easy. You're just looking for a missing side. In geometry class, you will see problems like this where you're going to do a little bit more with algebra. So I'm going to still start with the idea that I have to set up a proportion. I know the x plus 6 needs to be in there. That's one of my sides. Which side is it? It is from K to L. So I want to use the QR side. This little trick I'm showing you about using your similarity statements will help a lot when they give you all the sides. It's easier to get things confused then. So I'm going to put the 25 with the x plus 6 in one ratio. Now this right here in the upper part of the next one has to come from the triangle that the x plus 6 was in. So I'm going to put the 32 here, and that's going to go with the 40. From teaching, I can tell you that people understand the idea of similar triangles, and they know they're supposed to set up proportions, but they'll flip something over and have things not be lined up. So you got to be careful about that. If you have a proportion that's not working, just take your second ratio and flip it over. That's just a little tip. Now we cross multiply, and we're going to take 25 times 32, and that'll be equal to 40 times x plus 6. So I have 40 times x plus 6 equals 800. A lot of people are going to expect me to do distributive property here, and normally that would be what I would do, but I'm pretty sure I can divide 800 by 40. So I'm going to do that right now. And I get x plus 6 equals 20. There's another little algebra tip there. Now subtract 6 from both sides, you get x equals 14. If you needed to plug it in, you have 14 plus 6 equals 20, if they want to know the side length. Now see if you can do this one. The correct answer is x equals 10. Put your solution down in the comments. I'd like to see if you did it the same way I would do it. If this helped you out, give it a like, share it with someone, and hit that subscribe button. If you'd like to keep me caffeinated enough to make more of these tutorials, you can scan the QR code or use the link down in the description. I'll see you in this next super helpful video. Thanks a latte. Bye.